is large enough, it can collapse on itself to form a black hole. But if that star is very large but not large enough to become a black hole, it tends to explode into a supernova, eventually turning into a neutron star. A black neutron star is a mysterious dark object that may have appeared at the edge of our solar system. It looks like the remnant of a dying star. It is not a black hole, but it behaves like one. A black hole is not much different from any other massive object in the universe, except it is an entity with dense matter.
All matter contained within it is compressed into a point called the singularity.
This point is so small and dense that our understanding of time and space inside it is completely broken.
That singularity is what causes black holes to have an extremely strong gravitational force.
As for neutron stars, they form when a large star collapses at the end of its life.
Typically, neutron stars are about 1.5 times the mass of our Sun and have a diameter of only about 20 kilometers.
However, black neutron stars are too heavy to become a regular neutron star but too small to become a standard black hole. As of now, we do not have much information about these entities. So what would happen if you fell into one? Would it be like falling into a black hole? Imagine that the best scientists on the planet have devised a way to quickly wander around the vicinity of our solar system. And now you want to observe these fascinating entities up close. You know exactly where a black neutron star exists. Next, if you risk moving right into the center of this entity, what would happen? This mission of yours would require some special protective equipment, and this equipment would need to keep you safe from one of the strongest gravitational fields in the universe. This black neutron star would pull you toward it with a gravitational force about 2 billion times stronger than what you are used to on Earth. The problem is that the type of high-intensity gravity protection equipment you need does not exist at the moment. Without it, your mission would be like suicide.
As you get closer to a black neutron star, different parts of your body would experience different gravitational forces.
If you directly brush against this bizarre entity, your upper body would be stretched much more than your legs. As you approach its center, your body would be stretched out like spaghetti strands. But suppose that NASA's best scientists could provide you with a protective suit to withstand the extreme gravity, temperature, and radiation inside the black neutron star. Then your mission would become easier.
You would pass through each layer of an object with an incredibly large mass.
From the outside,
the black neutron star does not look like any other kind of star.
Hypothetically, it is covered by an extremely dark shell with very high density.
Regular neutron stars have extremely high temperatures, typically around 1 million degrees Celsius.
Thus, a black neutron star might have a similar temperature,
but astronomers still have no information about this mysterious entity. But it probably also has a very high temperature. First, you would pass through a layer of hydrogen and helium gas.
Then, you would move into the next layer of the star. Scientists believe this second layer could consist of iron and silicon. To continue your mission, you would need to somehow punch through this super solid, fiery surface. Everything would start to become dangerously dense. At the center of the black neutron star, you would notice some unique matter, possibly one of the strangest forms of matter in the universe.
Inside normal neutron stars, atomic nuclei are compressed so densely that they create the hardest matter ever known.
Now, you are so deep that the pressure level around you would be about 3 times higher than the density of an atomic nucleus.
Protons and electrons would combine into neutrons.
As these newly formed neutrons begin to pile up more and more, you would continue to move deeper.
Eventually, you would find yourself facing neutrons and protons compressed into quarks. As you approach the core of the black neutron star, you would nearly reach the maximum level of weirdness.
Among all the weak quarks around you, some would be so strange that even scientists call them strange quarks.
These quarks are heavier than other quarks and have their name from possessing a property called strangeness. All that means strange quarks are less likely to be torn apart by the electromagnetic force of a black neutron star. Inside this core, strange quarks would form a big mixture, simply called strange matter. Strange matter is contagious, meaning that when it comes into contact with normal matter, like you, it generates more strange matter.
So, as soon as you touch it, it would instantly disintegrate your protective suit and then your entire body.
If a star is large enough, it can collapse on itself to form a black hole.
But if a star is very large,
But not large enough to become a black hole. At that point, it tends to explode into a supernova and eventually becomes a brown dwarf. What has long puzzled scientists is that the smallest black hole has a mass at least 5 times that of the Sun,
while the heaviest brown dwarf ever observed is only 2.01 times the mass of the Sun. The range between these two limits is called the mass gap,
a mysterious range between black hole mass and brown dwarf mass that scientists call a black dwarf.
So far, there has been no concrete evidence confirming the existence of black dwarfs. New images of the Sun's surface reveal sunspots and some other structures with unprecedented detail.
8 images were released by the U.S. National Solar Observatory, NSO.
Taken by the Daniel K. Inouye Solar Telescope on Maui Island, Hawaii, USA.
Although the Sun is in a period of increasing activity, peaking in July 2025,
these images show a more peaceful aspect of the Sun's surface. The sunspot image shows bright hot plasma flowing up to the surface, while darker, cooler plasma streams sink downward. In the chromosphere, the Sun's upper atmospheric layer, elementary structures indicate the presence of magnetic fields. Another image shows a sunspot that has almost completely lost its surrounding penumbra.
Researchers believe this is the final stage in a sunspot's life cycle before it disappears. Researchers also captured light bridges, structures spanning across the darkest points in sunspots. These complex bridges have diverse shapes.
Scientists consider this a sign that sunspots are about to disappear.
The Inouye telescope is considered the largest and most powerful solar telescope ever placed on Earth.
Scientists expect this tool to help them answer questions about the Sun,
including the origin of solar storms and the complexity of the magnetic field surrounding this celestial body. Subscribe to the Hidden_Realms